Hey there, it's Mrs. Banky here. I am creating this recording for students who missed the water filtration engineering project and are needing to do an alternative assignment in place of what was missed in class. So I will introduce the project and what students experienced here, and you can use that as a reference in the remaining part of the assignment, of which more details will be given later. So this project involves starting with some dirty water, and I'll go get the dirty water quick. So we're waiting. So I have some dirty water here. There are chunks in there. There's going to be oil in there, chunks. It has an odor. It has discoloration. It's cloudy. And the goal is to get it as clean as we can possibly get it using a set of materials that are provided. So the objective is to clean this foul water. Students will get 100 milliliters of it, and success is going to be based on how much water you get back, how clear it is, whether or not there's still smell, and if the color has gone away. So here is a list of the materials that are available for students, and I'll just go through them quickly. Students do not have to use all of them, but there are some limits. So in an engineering project, these are called constraints. So you're building a filtration system that will get that water as clean as we possibly can within these constraints. And the constraints are the available materials. So we can use a ring stand with a ring. The ring stand looks like this in this image. It can hold a cup, it can hold a funnel, up to 5 coffee filters, a funnel, 1 styrofoam cup, 1 plastic cup, some aluminum foil, newspaper, paper clip, rubber band, cotton fabric, cotton balls, Q-tips, some sand and gravel. A mortar and pestle is used for crushing activated charcoal, which is used in fish tanks for making the fish tank water clear and odorless. It's highly effective at clarifying water, removing color, removing odor. And a cylinder, disposable pipette, plastic beaker, which the dirty water will come in, some plastic wrap, tape, stapler, and scissors. And the very last step is going to be 1 piece of high quality filter paper. So that's going to be for everybody. So the plastic on the left, you'll see the plastic beaker that the water is going to come in. This is what 1/2 cup of sand and gravel looks like. The final sample will be measured in the graduated cylinder. So there are some hints that I gave students. It's a good idea to try to get rid of the oil first, because oil clogs filter paper and coffee filters. So I encouraged students to remove the oil first without using coffee filters. And I gave them some hints that sand and gravel layers mimic Earth's natural water filtration system. However, if you have too much sand, it will absorb the water and you're not going to be able to get it. Cotton also absorbs water. So if you use too much cotton, you may end up having some of that water stay back and you won't be able to retrieve it. One of the most important components of water filtration in any water filtration system most of the time involves something called activated charcoal or activated carbon. And it's usually as a fine black powder or granules or pellets. And if it is in contact with foul water, cloudy water, water that smells, colored water, it removes odor and it clarifies water and it gets rid of color. So a hint that I give students is that the smaller the particle size, the longer the contact time, and the more you can agitate or have your water sample move within that activated charcoal, or have the charcoal move within the water sample, the more effective it will be. It doesn't matter how fine of a powder you make your activated charcoal. You can use a mortar and pestle to crush the charcoal. That charcoal will get trapped by that last piece of high quality filter paper. So these were the hints, strategies that I offered for students. If you're watching this because you were absent, what I'm going to have you do is I will have you watch the strategy that I used in the lab. Some of the materials I use in the lab were not included on this list, but the concept is still the same. So I'm going to have you use the strategies that I've used and watch my process as I take you through a video that shows how I took a sample of foul water and engineered a design to end up with a final product. So I'll have you watch that video, possibly answer some questions. Depending on the assignment that you get, you'll be asked to do certain things, and it may change from year to year. So I don't want to give any specific details with what, in addition to the video, beyond this video, what you'll have to do. You will get those details from me at the time that this pertains to. So thanks for watching. If you're absent, I wish you were here, and I hope you come back soon.